Yes, the rest on the platform. Can I hear your voice? Okay, I think we should start. What do you think? Hello, bro. I think we should start. Are you there?
Yes, sir. Yes, sir. Let's start.
Okay, so what are the things we did 2 days ago?
We looked at that the line could be correct but not precise. It could be precise
Yes.
but not correct.
Yes. What again?
And it showed us a graph.
Yes, I'm with you.
You showed us about AC and then DC, where we saw that AC is using is the one with high voltage, while DC is the one with low voltage. That we can use a voltage of 1.5 times battery to connect.
Yes, that's good. More.
I also learned that while plotting graph in determine the gradient, if we having I I I2 and I1, from the line of I2 you trace down. So that is how it could be correct. I2 minus I I2 minus I1 over V2 minus V1.
Okay. So that's a very good one. I really wish Ajayi, are you there or you are in a noisy place? Okay. So let's move on. Okay. Can you see? Okay, of course, I've not started sharing. I'm sharing slides now. Can you see the slide I'm sharing?
Yes, sir, I can see.
Okay. So the SI base unit, can you read slide 5?
Slide 5.
Yes.
SI base unit, quantity and unit, mass M equals to kilogram, length L equals meter M, time T equals seconds, electric current is in amperes, thermodynamic temperature is in Kelvin, amount of substance A is in mole, luminous intensity is in candela.
Now, the reason why we are reviewing this is that when you are taking your measurements, except otherwise stated, you have to keep to these units. For mass, if you take your measurement in grams, ensure that you convert it back to kilograms. Should I say that again?
No, sir.
Good. So if you take, like to measure mass now, we use a torque pound balance. So most times torque pound balance is rated in grams. So except in the question, they ask you to record it in grams. You have to convert to kilograms. You have to convert to kilograms. Now, if they ask you to do your table of reading in kilograms and in grams. When you finish your calculations, for example, if you finish calculating your slope, ensure that you return your answer to SI base units. Did you get that, or I should say it again?
Yes, sir.
No, which one? You got it, or I should say it again?
Say it again.
Good. If they ask you to take, for example, now they ask you to record your table of reading for mass in grams. Now, after finishing all your calculations and you've calculated your slope, so you will ensure that you put your final answer in kilogram for mass. Did you process that, or I should say it again?
I did. He said that when it's in gram, after
Yes.
calculating, I will put it in kilogram.
Good. Now, there are situations whereby on your table of values, they want it recorded in grams. So when you are plotting graph, they want it recorded in grams. Now, if you now use mass to calculate slope, to calculate the gradient of a slope, ensure that after getting your final answer, you return the mass to kilograms. Shall I say it again?
Yes, sir.
Now, this is what I'm saying. You know that there are times that when you are doing calculation, you solve problem with units that are not SI units.
Yes.
For example, mass that I'm talking about now, maybe you calculated your mass in grams. Okay, let me give you an example of what I'm saying. Now, can you see my whiteboard? Can you see my whiteboard?
Yes, sir.
Very good. Now, let's say you are given a container. This is the container. Is that taking?
Yes, sir.
Now, they will ask you mass of container in grams. So let's say the mass of container in grams is about, let's say 80 grams. Did you process that?
Yes, sir.
So now let's say this is 1 cm, 2 cm, this is 3 cm, this is 4 cm, and this is 5 cm. So they will now ask you to fill it with water up to 1 cm. Fill it with water up to 1 cm and measure again. So that will be your M1. So M1 will be the mass. So let's say M1 gives us 100 grams. So that is mass of water and container. Did you process that?
Yes, ma'am. Yes, sir.
Now, in this case, what's the mass of water for M1? What's the mass of water?
1
Did I
cm.
repeat the Did I repeat the mass of water, not height?
20 gram.
Good. So that is 100 minus 80. So that is 20 grams. Did you process that?
Yes, sir.
Now, they may now ask you to add more water until the height has gone to 20 cm. So in this case, you now have your M2. So let's say M2 is 120 grams. So in this case, what's the mass of water?
Come again, sir.
I should come again.
Yes, sir.
Now, they said you should add more water until the water level has moved from 1 cm to 2 cm, until the water level has moved from 1 cm to 2 cm. And they now ask you to weigh the container again. The container filled with water up to 2 cm. And what you weigh is now 120 grams. What you weigh is now 120 grams. So in this case, what's the mass of water in the container?
20 grams.
How did you get 20?
Sorry, it will be 100.
Now, how did we get mass of water when it was filled up to 1 cm?
We got it by subtracting 100 grams, which is the mass of the water from
No,
the mass of the
100
container.
grams is the mass of container and mass of water at 1 cm. Is that not?
Yes.
Good. So how did we get mass of water only at M1?
Subtracting 100 from 80.
Good. Now, how do we get mass of water only at 2 cm now?
It's 40, sir.
So it's going to be 120 minus what?
80, which is
Minus
40.
80 grams. So that is 40 grams. Now, did you get the illustration?
Yes, I do.
So as the height of the water is increasing, what is happening to the mass of water?
Also increasing.
Very good. So you must pay attention to those trends. Immediately you are filling your table of values and the trend is not increasing or decreasing. Maybe it's increase, decrease, increase. Then you should know there is a mistake somewhere. Shall I say that again?
No, sir.
Very good. Very good. Now, all these masses we have calculated, they are in what?
Ground.
Very good. Now, if they now say you should plot the graph of mass against length, plot the graph of mass in grams against length in cm. Are you with me? Is it going
Yes.
to give us a straight line or a curve from what we have seen?
A straight line.
A straight line graph. So is it going to be a positive gradient or negative gradient?
Positive.
Very good. Very good. Because as the length is increasing, mass is also increasing. So it's likely a straight line graph passing through the origin. So now, now in this case, how do you calculate the slope? How do you calculate the gradient of the slope in this case?
M2 minus M1 over L2 minus L1.
Very good. So change in M over change in L. Now, what's the unit for M? The unit for M is what?
Mass. That's kilogram.
Yes, the unit.
Is
So your answer will be something like, let's say 2 grams per what? What's the unit for length that we used in the experiment?
centimeter.
Centimeter. So what will be the unit of the slope?
Grams and centimeter.
Very good. Gram per centimeter. So gram per centimeter, is it an SI base unit? Gram per centimeter, are they SI base units?
No.
Sorry, hope the pressure is not too much. You are the only one that I see that
No,
is
sir,
there.
not.
So, sorry. Okay. So gram per centimeter, are they SI base units?
No, sir, they're not.
They are not.
They're not.
So we convert from gram per centimeter to what?
Gram per kilogram.
So we convert from gram per centimeter to kilogram per meter. Shall I say it again?
No, sir. Okay.
Good. So now, how do we now convert from gram per centimeter to kilogram per meter? So this is the same thing as 2 grams over 1 centimeter. Did you process that?
Yes, sir. Yes, sir. Continue.
Sorry. Okay, can you hear me now?
Yes, I can.
Good. Can you still see my whiteboard?
Yes, I can.
Very good. Now, so this so this is the same thing as 2 times grams, 2 times 1 gram times 1 over 1 centimeter. Did you see that?
Yes, sir.
So to convert 1 gram to kilogram, you divide by 1,000. So that will be 1 over 1,000 kilograms times, to convert 1 centimeter to meter, you divide by what?
100.
Very good. You divide by 100. So we now have 2 times 1 over 1,000 kg times 100 over 1 cm. Did you process that?
Yes, sir.
So this 0, we cancel this 0. So at the end of the day, we are going to have 2 kilogram over 10 cm. So that is 0.2 kg, I mean meter, not cm. This is meters. Yeah, meters. So kg per meter. So we have converted our final answer, since they said in the experiment that you should record your mass in grams and the length in centimeter. So that's what we use throughout for the table, for the graph. Then final answer, like for this gradient, we now convert to SI base units. Is that clear?
Yes, sir.
Good. So can we move on now?
Yes, we can.
All right. Now, the same thing also applies to length. Don't forget that 10 millimeter make 1 centimeter, 10 centimeter make 1 decimeter, 10 decimeter make 1 meter, 1,000 meters make 1 meter. make 1 kilometer, 1,000 meters, make 1 kilometer. So those conversions, especially when you are using millimeter to meter, you divide by, you multiply, divide by 1,000. Millimeter to meter, you divide by 1,000. Milliampere to ampere, you divide by 1,000. When you are converting from degree Celsius to Kelvin, what do you do? How do you convert from degree Celsius to Kelvin?
Use of 273.
Add 273.
So we add 273 temperature in degree Celsius to get the one in Kelvin. All right. So the SI base unit of time is seconds. Very important. So I've explained the digital and the analog, the apparatus the other time, the meters, the analog and digital stopwatch. So for temperature, what instrument do we use in measuring temperature? What instrument do we use in measuring temperature? Are you there?
Thermometer.
So we use the thermometer in measuring temperature. Very good. So thermometer. Okay. So what instrument do we use in measuring electric current? What instrument do we use? Yes. What instrument do we use in measuring electric current?
Diameter, sir.
So we use the ammeter. Good. Now there are times that, very good, ammeter. There are
Hello, sir. Can
times
you hear
that
me?
the maximum, yes,
I'm saying something.
yes, I can hear you. Can you hear me? I can hear you. Can you hear me now?
Yes, sir. I can
Good.
hear you.
So please pay attention to the
I'm going out, though. I'm going out. I'm going out. I want to lock the gate. Eh? The power. Yes. Which one?
So can we move on now?
Yes, sir.
Okay, Esther. All right, Esther, are you there? Bakari, Ariana, are you there?
Yes, I'm here.
Yes, sir. Yes, sir.
So what instrument? So when you are using the ammeter to measure electric current, you must pay attention to the calibration of the ammeter. Some are calibrated in milliammeter, so you must pay attention. Then some, the maximum current on it is 5. Some, the maximum current on it is 3. So can you see an ammeter on my screen now? Can you see ammeter on my screen? Can you see ammeter on my screen?
Yes, sir.
Now, I'm not sure. Can you hear me?
Yes, sir.
So you see Hamilton on my screen, right? So this is voltmeter. Have you seen voltmeter? Ah,
Yes, sir.
have you seen? You've seen the voltmeter.
Yes, yes.
So this one, is it analog or digital?
Digital. Digital.
This is analog. This is what?
Analog.
Analog.
Good. So it is the ones that used to look like wall clock. They are the analogs. So now this is multimeter. Now, what's on the screen now? What can you see on the screen?
Multimeter.
Very good. This is multimeter. So this one is it analog or digital?
Digital.
Very good. So I don't know, most schools they still use the analog, but in case you come across the digital, that's why I want you to see it. So you will notice that you can use multimeter to measure resistance, current,
Digital.
voltage. Yes, this is digital. So that's that. Okay. Okay. Good. All right. So who is reading slide 6 now? Slide 6. Who is reading slide 6? Yes, who is reading slide 6?
Okay.
Slide 6.
We are here. We are here, sir.
Yes, yes. Please
10
read
raised to
slide
power
6.
minus 1 is decimeter. And 10 raised to power
Good.
minus 2 is centimeter.
Centi.
10 raised to
Yes.
power minus 3 is millimeter. 10 raised to power
Milli,
minus 6
milli,
is micro.
micro. Yes.
Okay, it's micro. 10 raised to power minus 9 is nano. 10 raised to power minus 12
Yes.
is pico. 10 raised to power minus
Yes.
15 is femto.
Yes. So you need to pay attention to centi, especially when you are using your 30 cm ruler to take measurement. For example, if your question is on equilibrium of forces, and you are calculating distance between masses, most of the time you take your reading in centimeter. So to convert to meter, you divide by 100. Then milli, for example, if you are measuring current, milliampere. So you must have to convert from milliampere to ampere. You divide by 1000. Is that clear? Is that clear, or I should say that again?
It's clear.
Clear.
Okay, so let me ask you, especially our sister that just joined, if you take a reading, let's say the reading is 120 milliampere. So how do you convert that to ampere? How many ampere is that? Yes, how many ampere is that? One 20 milliampere is how many ampere?
I this is 0.1.
That's 0.12. 0.12. That's okay.
Yes, sir.
Okay. So how about 150 cm in meters? 150 cm in meters.
That is 1.5.
Very good. That's 1.5 meters. So you've gotten that, so we can move on. All right. So now slide 7. Sister Aya, read slide 7 for us. Is she still there? She has gone. Hey. Are you still there?
Yes,
I
sir. I'm
can't
still
see.
here.
Okay, yeah, slide 7.
Multiple of units,
Yes.
prefix
So
and power.
multiples of units. Yes, prefix and power. Yes.
Deca, 10 raised to power 1. Kilo,
Deca,
10 raised to power 3. Mega,
kilo,
10
times
raised to
by
power
3.
6.
Yes.
Giga, 10 raised to power 9. Tera, 10 raised to power 12. Beta, 10 raised to power 15. Exa, 10 raised to power 18.
Good. So attention should be on kilo and mega, from grams to kilogram. So if you measure something as 20 grams, so 20 grams in kilograms is what? 20 grams, convert that to kilograms is what?
0.2
Is it 0.2?
to kilograms.
Yes, to kilograms. 20 grams to kilograms.
0.02.
Very good. 0.02. Is that taken?
Yes, sir.
Yes, sir.
So that is kg. Okay. So slide 8. Yes, slide 8. Who's reading slide 8 now?
Measurement of length. Using the meter rule. When taking readings, your line of sight should always be perpendicular to the scale that you are using. Otherwise, you will introduce parallax error.
Very good. Now A major instrument that you make use of in physics practical, especially mechanics, is a meter rule. It can be your 15 cm rule, it can be your 30 cm rule, it may be the 100 cm rule or the 1 meter rule that you are giving. Okay, meter rule. So this is a meter rule. Can you see a meter rule now? Can you see that white plastic? Can you see that white plastic?
Yes, sir.
Yes, correct. So that's a meter rule. Some it is yellowish wooden. This one is plastic, but it may also be wooden. Is that taken?
Yes, sir.
Now, do you see that silver something with anger? That's what we call mass anger. Do you see mass anger there in front of the meter rule?
Yes, sir.
So that is the and it has a specific value on it. So if you look at the slide, you need to pay attention to the calibration of the meter rule. Either it is calibrated in mm or cm. Is there a difference between the two? Is there a difference between a ruler that is calibrated in cm and that which is calibrated in mm? Is there a difference?
Yes. There's a difference.
So what's the difference? Yes, what's the difference?
Difference between what, sir?
Between a rule
Centimeter is
that is
greater
calibrated in mm.
than millimeter.
Okay, so how many millimeters make 1 centimeter?
10 millimeter.
So good. So in 1 centimeter, you get 10 millimeters. Now, the second diagram, we have AB. Do you notice ABC on the second diagram?
Yes, sir.
So which of the ABC is the correct way of taking reading using a meter rule?
B.
B.
E. So, yes, slide 9. Who's reading slide 9?
The smallest measurement of length using a meter rule. The smallest
Yes.
reading on a meter rule is 1 millimeter or 0.1 centimeter.
Good. Now, this is what we are saying here is that if you are asked to record, to make readings, and you are using a meter rule, if you are asked to record readings and you are using a meter rule, are you with me?
Yes, sir.
Now, your measurement should be to the nearest 1 millimeter or 0.1 cm. Are you with me?
Explain better, sir.
Very good. Can you see my whiteboard?
Yes, sir.
Now, I am using meter rule to take the length of a rope for a simple pendulum. I am using meter rule. So if they ask me to record my readings in cm, so I will have 10, 20, 30, 40, 50. Are you with me?
Yes, sir.
Now,
Yes, sir.
these measurements, they are to the nearest what?
Centimeter.
They are to the nearest centimeter. So these values, they are not accurate because I'm using meter rule, and the smallest measurement on the meter rule in cm is what?
0.1.
0.1.
2W, 0.1 cm. So my answer should carry 10.0, 20.0, 30.0, 40.0, 50.0. So that shows that I have taken the reading to the nearest 0.1 cm. Should I say that again?
Got in, sir.
Gotten. Now, for the millimeter, what will be the answer for number 1?
1.
1,
So
yeah.
that's 1. That's 1. For number 2, what will be the answer? And
Yeah.
okay. For number 2, what will be the answer?
2.
2.
2. For number 3, what will be the answer?
3.
For number 4, what will be the answer?
4.
For number 5, what will be the answer?
5.
Now, 10.0 and 1, are they the same?
No.
So
Sir,
this answer
excuse
is
me.
wrong.
Sir, excuse me.
10.0 and 2, are they the same?
No, sir, they are not.
So this answer is wrong. 30.0 and 3, are they the same?
No, sir.
So what will be the correct answers now?
Pardon.
What are the correct answers now? For L in mm,
It should be 1.0.
1.0 and 10.0, are they the same?
0.1.
No.
But sir, please, how did they get that one?
Now, you've done well. Now, two things has happened here. Two things have happened here. Two things have happened here. I now got why you are saying 1, 2, 3, 4, 5. Now, the way they got one was that they divided cm by 10 to get mm. Did you process that?
Yes, sir.
So 10.0 cm and 1 mm, they are the same. Is it not? Ah.
Yes, sir.
20.0 cm and 2 mm, they are the same. Is that taken?
No, sir.
Now, convert 10 cm to millimeter. How do you convert from centimeter to millimeter?
Divided by 100.
Centimeter to meter. How many millimeter make 1 centimeter?
10.
10. So, if you convert 10 cm to millimeter, what will the answer be?
1. 1
1.
millimeter.
So, is that taking any? Is it clear?
But sir, will it be 1.0?
Very good. That was where I'm going to. It won't be 1.0 because you are using meter rule. It's going to be 1 mm. Shall I say that again? The smallest reading on the meter rule is 0.1 cm or 1 mm. So anything less than 1 mm is an estimated value. Have I answered that question?
Yes, sir.
Okay, now I want you to tell me now. I want to record L in mm. Serial number. This is 1, 2, 3, 4, 5. Serial number. Serial number. Serial number. So your table should be enclosed. So you will tell me which of A, B, C, D. You will tell me which of them is correct. I'm using meter rule to take a measurement and I'm recording it in mm. So the first one is 10.0, the second one is 20, the third one is 30.0, the next one is 40, the next one is 50.0. So can you see my whiteboard?
Yes, sir.
So which of A, B, C, D, E are correct for recording in mm a reading taken using meter rule? Which of them are correct?
B, B and D.
B and D are correct. A, C, and E are wrong way of documenting or recording a measurement made using meter rule in mm. Who has not gotten that point? Has everyone gotten the point?
Yes, sir.
Very good. Now, the next thing I want to talk about is the decimal places and the significant figures. So if we now have serial number, we have length in centimeter, then we now have inverse of length. So this is 1, 2, 3, 4. So we now have 10.0, 20.0, 30.0, then 40.0. So this is A, B, C, D. So what will I put in column A? What will I put in column A?
0.1.
0.1, 0.1, 0.1. Okay. Column B.
0.2.
Where are the rest? 0.2. Column C.
0.3.
0.3. Column D.
0.4.
0.4. So as everyone agree with that?
Yes, sir.
Everyone agreed with that, right?
Yes, sir.
All right. Now, pay attention now. What's the difference between L and L h power minus 1? What's the difference between the two?
Inverse.
Good. Did you pay attention to that here? Did you pay attention to that here?
Yes, sir. Yes,
Yes,
sir.
sir.
So what's the inverse of 10?
0.1.
What's the inverse of 20?
0.2.
Inverse of 20 is 0.2. Inverse of 20
1.
means 1 over 20. So what's 1 over 20?
0.05.
0.05. 0.05. So this one should be 0.05. Is that clear?
Yes, sir.
So C, what will the answer for C?
0.03.
1/30. 0.
Yes, sir.
0.3.
Is it 0.0 or
0.03.
0.03?
Okay,
0.03. 0.03.
Good. Now, how about inverse of 40? 0.025.
0.025.
0.025. So as L is increasing, what is happening to L inverse? As L is increasing, what's happening to L inverse?
It's decreasing.
So you have to pay attention to those cases. It either is increasing down the column or is decreasing. So you must pay attention to that trend. Now, are you with me?
Yes, sir.
Yes, sir.
Please, go. How many significant figures is this? How many significant figures?
2.
I mean, let me use
Which one?
another.
Which one, sir?
Let me use another. Can you see this one that I circle with green ink?
Yes, sir.
Yes,
How many
sir.
significant figures is that?
1
3.
2.
is
So
1.
it is 3 significant figures. 3 SF. Because 1 is non-zero. So you start counting from 1. So any digit that comes after a non-zero digit is significant. So that one is 3 SF. How many decimal place?
1 decimal place.
1 decimal place. 1 decimal place. Should I explain that again or is taking?
Sir, I don't understand how you use 3 significant figures.
Very good. You know it is 10.0. It
Yes,
is
sir.
10.0. So 1 is significant. So you count 1, 2, 3. So that makes it 3 significant figures. Did you see that?
Sir, is it because it's in centimeter that
No,
is significant figure, or it's just normal?
no. You start counting from the non-zero digit. And what's the first non-zero digit?
1.
So that's how to count significant figures. Shall I give you one question for you to know if you've gotten it?
Okay, sir.
So 0.23 is how many significant figures?
1 significant figure.
How many?
1.
Where did you start your counting from?
3.
You start counting from the first non-zero digit, which is 2. So this is 1, 2. So this is 2 SF. Do you process that?
Yes, sir.
Will I give you one more?
Okay, sir.
So 0.1010 is how many SF?
4.
Very good. Will I give you one more?
No, sir.
Okay, so let's continue. So 10.0 is how many decimal place?
1 decimal place.
Good.
3.
Now, when we now got how many decimal place? 10.0.
You said it's 3.
What did you say? 10.0 is how many decimal place?
3.
It's not 3. Decimal place, you start counting after decimal point.
Oh,
So how many
sorry.
digits do we have after
It's 1
decimal
decimal
point?
placing. I
How
was
many?
taking it to SF. Sorry. I was taking it to SF.
Yeah, so this is how many decimal place? 10.0 is how
10.0 is
many?
1 decimal place. 1.
One decimal. Yes, 1 decimal place. How about 0.23? How many decimal places?
2 decimal place.
So that's 2 decimal places. 2 decimal places. Is that clear?
Yes,
Yes, sir.
sir.
How about 0.1010?
4.
4 decimal places.
So that's 4 decimal places. Very good. Now, let's now take that back to our table. Now, for L inverse, this is how many decimal place?
2.
1.
No, inverse for 10.0.
Okay, 1. Sorry.
That's 1 decimal place. How many SF?
1 SF.
So if you check L is how many SF?
Eh?
L 10.0 is how many SF?
3.
The L inverse is how many SF?
1.
So you will take this one to 3 SF. So the answer you will record will be 0.100. Did you see that?
Yes, sir.
So this is how you will record your L inverse, not like this. This is how you record your L inverse.
Noted.
You process that.
Noted, sir.
So for 20.0, how will you record your L inverse for 20.0?
0.050.
So it's going to be 0.0500.
Sir.
Sir, is it not 4 decimal point now?
No, we are not using decimal points now. You are using SF. 20.0 is how many SF?
Okay, 3.
So 0.050 is how many SF? This is how many SF?
3.
Is that taken?
Yes, sir.
Or I should explain again.
So where I'm confused is that
Yes.
so that why in your table that in your table that
Yes.
it should be, if you are making it to be 2 decimal places, it should be that you down.
Yes. That's for decimal places. That's for the first reading that you use instrument to take. That one is for reading that you used instrument to take. You used meter rule, you used vernier caliper, you used micrometer screw gauge. For cm, if you are recording in cm and you use meter rule, that's 1 decimal place. If you use vernier caliper for cm, that will be 2 decimal places. For micrometer screw gauge, if you are recording in cm, that will be 3 decimal places. So you will maintain that throughout the column. But when you are calculating inverse, you are adding, you are doing product, that is where SF comes in. I should explain that again, or it's taken?
Taking some.
All right. So for 30.0 inverse, what would be the answer?
Zero point 0.0300.
Good. Then for 40.0 inverse, what would be the answer?
0.0250.
Good. So it's going to be 0.250. This will be 0, 0. So this is, how many SF is this?
3.
How about B?
3.
So we are maintaining the same SF, 3SF for L inverse. So if you feel like the values are too much, then you can now reduce them to 2SF, but make sure you approximate well. So that is also allowed. If you reduce them to 2SF, we are still okay. So that will still not cause any trouble. Did you hear what I just said?
Yes, sir.
So for 2SF, what's L inverse? For 10.0, what's the L inverse in 2SF?
0.10.
For 20.0,
0.050.
for 30.0,
0.030.
good. For 40.0,
0.025.
good. So you discover that our answers are consistent, they are in consistent SF, and the values are not affected. So is that it? Can we move on?
Yes, sir.
All right. So 10.
Measurement of length. Using the die vanilla caliper. Calipers are designed to grip an object with two jars used to measure the internal and external diameter of objects.
Now, if they want you to take measurement using the vernier caliper, of course, the length of the object is not large, then it's likely the object is circular in shape. Very likely. So in that case, the blue part, that's how to use a vernier caliper. And like I said, the smallest reading on a vernier caliper is 0.1 in mm or 0.01 in cm. So 0.1 mm is how many decimal place?
1 decimal place.
Good. One decimal place, how many SF?
1 SF.
0.01 cm is how many decimal places?
2 decimal places.
Good. How many SF?
1
One.
SF.
Good. So 0.1 mm and 0.01 cm, do they have the same SF?
Yes.
Yes.
Very good. Because we are still measuring the same length. So they have the same SF. So that is what you have to pay attention to in recording. Right. 12 now.
Measurement of length using the micrometer screw gauge. The micrometer screw gauge has two scales, the main scale and the fractional scale.
Okay. In our last class, give you a graph to plot. Did any of you plot the graph?
No, sir, I did not.
Okay, so let me get responses from others. Yes.
No.
Okay. It means Esther. Esther is there. Is Esther there? Or is it Ariana that responded? Who responded now? Who responded now?
It's me.
No. Who is me?
Marvelous.
Marvelous. That's Bakari, Abi.
Yes, sir.
Okay, the remaining candidate there, Esther and Ariana. Are you still there?
Sir, I wanted to plot, but the network logged me all out the that day, so I couldn't get the instructions. When I requested for the recorded this thing, I couldn't do it again.
Now, are you in the house? Esther, are you in the house?
Yes, sir.
Do you have your graph book, your pencil, your ruler with you?
Yes, sir.
Go. Who else is in the house and he or she has pencil, ruler with him or her? Who else?
I don't have a graph sheet with me.
Okay, who else? You are in a place where you
I
could
did not
plot
do my due to
and you
exam
have graph
schedule, sir.
again.
I did not do my due to exam schedule time and tension.
Hey, I didn't get that.
Sir, I did not plot my graph due to exam schedule time and tension over jam
Exam
receipting.
due time and tension of UTME. Okay, sorry for that.
Receipting.
Yeah, yes. Are you receipting?
Yes, sir.
Oh, sorry for that. Sorry for that.
And
Were
it
you
clashed
scheduled
with
for
my
that?
agri practical tomorrow.
When were you rescheduled to do the UTME?
9 a.m. agri practical 9:30.
Friday or Saturday?
Tomorrow.
Hope the venue are close by.
They are not or they are far.
And have you notified JAM?
I don't know how to, sir.
Okay. Did they send you text message?
Yes, they have. I've printed my slip.
Yes. The number they use to send you text message, is it code or phone number?
It's a code 55019.
Is a code. Okay. You need to call the Agric people in your school and inform them, because JAM has made arrangement with them so that they can make arrangement for you. So
Sir,
that's one step. Another
sir,
step is okay.
I think they said that they don't want to hear that you have exam or not.
No,
That they
no,
don't.
they didn't say so. I still read the update today. They didn't say so. The JAM has liaised with WAEC and WAEC have agreed. So the next thing to do now is to let the people in the school where you are doing agri practical, do you have any of their phone number?
Yes, sir.
Please call any of them, either the agri teacher, the principal, or please call them and inform them ahead. That's number one thing to do. Number two thing to do is that just browse JAMB office in Lagos. When you browse, it will bring you some contacts. So those are the phone numbers to call. Did you get that?
Yes, sir, I did. I do.
Now, the third thing you could do is JAMB office, Abuja, hotline. That's the third thing to do. So by the time you contact those three, of course, you should have proper information on steps to take. So I will advise you to call those numbers, then go for UTME in the morning. Then when you are through, now go for a great practical, please.
Thank you so much, sir.
God bless you, brother. Sorry for the inconveniences. Okay, so who else is in the house and have a graph book, graph sheet, and a pencil and ruler?
I have my graph, but there's no ruler here.
No math
Sir?
set, no pencil, no pencil, no mathematical set.
I said there is no ruler.
Set. Okay, let's continue. So I'm just trying to see a way to guide you on plotting graphs. So it's only Esther that is in the house and she has graph book, pencil, right? Or is he Favor? Is he Bakari that?
Is Esther?
Yeah. So you have your graph book, you have pencil and ruler, right?
Yes, sir.
So please pay attention so that when time comes, I'll guide you on how to. So if you are having challenges, I'll be able to relate. Since nobody did the exercise and submitted, so I want to know because graph table, they carry a larger portion of the scores for practical physics. Graph tables, they carry a larger portion. Okay, so when we get there, we'll make use of that. All right, so the micrometer screw gauge, we have the main scale and we have the fractional scale. So yes, slide 13 is using slide 13 now. Slide 13.
Measurement of length. Using the micrometer screw gauge, one rotation of the barrel moves the end of the barrel 0.50 mm along the shaft. The barrel has 50 divisions, so each division represents 0.01 mm. Read the main scale to the nearest 0.5 mm. Avoid zero error.
Very good. Now, I'm starting with avoid zero error. To avoid zero error, make sure that when you have not put anything on the micrometer scale to measure, make sure that the main scale and the circular scale, they are overlapping. They are overlapping. This is what I'm saying. For example, if you want to measure current and you have not placed anything on the ammeter and the ammeter is already reading 0.1 or 0.2 or 0.3, that is zero error. That is what?
Zero error.
You have not taken measurements and yet there are readings already. So that is zero error to look out for. Zero error to look out for. So the same thing also applies to micrometer screw gauge. You must look out for something like that. Okay, so now when you are taking measurement with micrometer screw gauge, your reading will have two decimal places if it is in mm. But if it is in cm, how many decimal places?
One. One decimal.
If it is in cm and you are using micrometer screw gauge, your reading will be in how many cm? And your reading will be in how many decimal places? You are using micrometer screw gauge.
Okay, 2.
In mm, how many decimal places?
One.
Are you sure you are following this thing?
Yeah, is
I said in mm, the smallest reading 0.1 How many decimal places is that? 0.1 How many decimal places is that?
1.
No, 0.1 is how many decimal places?
1. Okay, 2. 2.
Are you there?
Yes, sir.
0.1 is how many decimal places? 0.1
I said 1.
Okay. Now, please, are you there?
Yes, sir.
Good. Now, do you see 10.0 here? Let me use red ink. Did you see
Yes.
this 10.0?
Yes, sir.
It is how many decimal places?
Is 1.
One. Do you know why?
Sir?
Do you know why?
I didn't get you, sir.
Yes. Do you know why it is one decimal place?
Please, I can't hear you.
Okay, can you hear me now?
Yes, sir.
Do you know why 10.0 is one decimal place?
Yes, sir.
Why? Why? Why is it to one looking to one decimal place? How do you know?
Because 0 is after the decimal point.
Okay. Now, how about 0.23? That's how many decimal places? 0.23.
2.
How about 0.1010?
4.
Good. So my question now is 0.1 cm, 0.1 is how many decimal places? 0.01
You were saying 0.1 instead of 0.01.
Sorry, 0.01
It's 2.
2 decimal places. So if you now convert that to cm, what do we have? If you convert that to cm, what do we have?
We have 0.1.
How do you convert from mm to cm?
To cm, you divide by 100.
No. Even if you
By
divide by
10.
100, okay, you divide by 10. So if you divide 0.01 by 10, what do you have?
10.
0.01 divided by 10.
Okay.
Do you have your
One,
calculator there?
1.00.
No, no. 0.01 divided by 10. 0.01.
0.001.
0.01 divided by 10 is what?
0.001.
Good. So 0.01 mm. If you convert that to cm, what do we have?
0.001.
Very good. So 0.001 cm is how many?
Sir, I can't get you.
0.001 cm is in how many decimal places?
3.
You see that? So that is the reading accuracy of micrometer screw gauge. That's the reading accuracy of micrometer screw gauge. Is that taken?
Yes, sir.
So that's that. Okay. So slide 14 now. Read slide 14.
Types of error. Systematic. They are due to weakness of the instrument. They are due to wrong calibration. Examples are zero error, that is fixed error on the scale. Parallax error. It could be reduced by recalibrating the instrument. Random error due to the experimental inadequacies. It could be reduced by taking multiple measurements and averaging the results.
Good. Now we have two basic types of errors. We have the systematic and the random. Now, when you say systematic error, it means that the error is consistent. Are you with me?
Yes, sir.
Now, let's say that the time now is 8 o'clock. Let's say the time now is 8 o'clock. In 1 hour time should be what?
9 o'clock,
In 2 hours time,
10 o'clock,
in 3 hours time,
11,
in 4 hours time.
12.
Good. Now let's now say that somebody's else clock now, stopwatch now is reading 8:05. That's what the clock is reading now, 8:05. In 1 hour time, what will that clock read?
9:05.
What's the difference between 8:05 and 8 o'clock?
5. 5
What's the
minutes.
difference between 9:05 and 9 o'clock?
5.
That difference is consistent.
Sir?
The difference between the true value and the measure value, is it consistent? Is it the same?
Yes, sir.
So that's what we call systematic error. So it's usually due to zero error in the instrument. Maybe the person is not looking at the right angle, or the instrument already have a deficit or an excess before the reading is being taken. Is that clear?
Yes, sir.
Should I explain that again?
No, sir.
Good. So you must make sure that the ruler you are using to take your reading, the 1 cm is there, 0 cm is there. Don't use a ruler that the 0 to 1 cm have been chopped. You need to watch. Then make sure that the 1, 2, 3, 4, 5 is consistent on the meter rule to avoid zero error and systematic error. So by recalibrating, I've explained parallax error the other time. This is parallax error here. Can you see it? Can you see that ABC?
Yes, sir.
So I use that to explain the parallax error. So error due to the experimental inadequacies. Maybe when you are supposed to stop the stopwatch, you were still talking, or maybe you started the stopwatch before the oscillation was completed. So those ones, you can reduce them by taking multiple measurements. So if they ask you to record time for 10 oscillations, if they ask you to record time for 10 oscillations, so you do it 3 times. Now, I've explained oscillation before. I've explained one oscillation before. So let's say we have a bulb. This is a bulb. Can you see my whiteboard?
Yes, sir.
All right. Now, when the bulb go from A to B, that's half oscillation. Should I say that again?
No, sir.
No, sir.
When the bulb return back to A, that's a complete oscillation. That is one oscillation. Should I explain that again?
Yes, sir.
Now, if you release the pendulum bulb from A and it goes from A to B and return back to A, that is one oscillation. That's one complete oscillation. Shall I say that again?
No, sir.
No, sir.
All right. So if they ask to take for 10 oscillations, so you will now do it T1 for 10 oscillations, let's say 7.0 seconds. If you are using analog stopwatch, then you now record T2 again. So let's say 7.2 seconds. Then you now record T3. So let's say 6.9 seconds. So these readings, what can you tell me about their precision, the precision of these readings?
It increased and then decreased.
Yeah, what can you tell me about the precision? Is it highly precise or not precise?
Not precise.
Why did you say not precise?
Because it's not moving high, neither is it moving low.
Okay, any other comment?
I think it's precise
Why do you think it's precise?
because all of them, when approximated, will still give 7.
Very good. If you approximate the three of them, it will still give 7. So that is precision. So that is precise. Did you remember I explained that yesterday? When values are very close together, that's precision. Is that clear, or I should explain again?
It's clear, sir.
It's clear. Now, let's say that another candidate did the same thing, the same experiment. So the T1 is 7.0 seconds, the T2 is 7.1 seconds, and then the T3 is 7.5 seconds. Is this precise?
No,
Why did you say no?
sir,
Why did you say no?
because T3 will give 8.
Very good. So you will not use T3 or you will do T3 again. You will not use T3 or you do T3 again. Is that taken?
Yes, sir.
Now, how do you find the average for these readings? How do you find the average?
C1 plus T2 plus T3 all over 3.
So yeah, stop it. What's the answer?
Sir, it was
7.08.
7.0.
7 point 7 point what?
03.
So that's 7.0 seconds. Very good. So T is equal to 7.0 seconds. So now, how do we calculate period? How do we calculate period in that case? What's the formula for period?
1 over F.
We don't have F. We only have a number of oscillation. Yes. What's the definition for period?
Period is the time uh, where number of time.
Period is time over number of oscillations. Shall I say that again? Period is time over number of oscillations. Shall I say that again?
No, sir.
So for this oscillation, what's the period?
1
7
over
over 3.
7.0 over 10. So that will give us what?
Over 10 abi over 3, sir.
How many
Over
oscillations
time.
did we?
3.
No, 3 is for average. N is for number of oscillations. Did you see the N here?
Okay, sir.
So 3 is for average. And if the readings you are taking, like here now, if you are using only 2 readings, if you are using these 2, how will you get the average for T1 and T2? If you are using only T1 and T2, how will you get the average?
T1 over T2. T1 plus T2 over 2.
Good, good. So how do we get the period here now? So what's the period?
0.7.
0.7 second. Is that how you will record it? So how you will record it
So is it in seconds?
in seconds? Are you with me? Are you there?
Yes, sir. Yes, sir.
So for the time 7.0 seconds, how do we record the period?
0.7. 0.7.
0.7. Is it 0.7 or 0.70?
Yeah, 0.70 because it's in two significant feet. Yes, it's 0.70.
Hmm. How about for 8.0?
0.80.
0.80.
0. For 9.0
9.
and for 7.0.
0.10.
0.
0.1.
0.10.
0.100.
Are you sure it's 0.100? What is 10.0 divided by 10?
1. So it's
1.
So how do you record it? How do you record it?
1.2. Sir? 1.
1.000.
No.
How many estimates is our target?
3.
1.00.
So that will be 1 point what?
0.
0. 0.
Is it 1.0 or 1.00?
1.0.
1.00.
1.00 is how many estimates? 1.00 is how many estimates?
3.
3.
So our answer here is it can take 2 SF, it can take 3 SF, so you will not be penalized. Is that taking?
Yes, sir.
So now who is doing slide 15?
Calculating percentage error. Percentage error is equal to error over true value times 100%. Error is equal to true value minus measured value.
Okay, slide 16 now.
Sir,
Read slide 16.
I can't see slide 16 well.
You can zoom your screen.
Okay. Table of values. decimal places, and significant figure. I should read the values there.
Yes, please read.
Okay. 1 is 80.0 in cm and 0.23 in ampere. That's current. 2 70.0 cm and 0.25 ampere. 3 60.0 cm and 0.31 ampere. 4 50.0 cm and 0.34 ampere. 5 40.0 cm and 0.39 ampere. 6 30.0 and 0.43 ampere. 7 20.0 cm and 0.46 ampere.
Okay. Now, after the I against A, the current in ampere, what's the next column? What's the title of the next column?
D inverse, is it distance?
Inverse. So,
Sir?
what will be the answers for D inverse now?
Okay, sir?
So, what we do now is that we complete the table. Is that taking?
Yes, sir.
You snap it to the admin. Admin will send it to me. Then you now plot the graph of I against D inverse. You plot the graph of I against D inverse. Is that taking?
Sir, please let me screenshot this thing.
Yes. So you plot the graph of I against D inverse, then you now calculate the gradient of the slope. Have you seen it?
Yes, sir. Let me. Yes, sir. I've
So you
taken it.
plot the graph of I against D inverse. You plot the graph of I against D inverse, then you now calculate the slope of the graph. You calculate the gradient of the slope of the graph. Shall I say that again?
No, sir.
So you compute the table, you snap it to the admin they send to me, then you now plot the graph. On the graph, you calculate the gradient of the slope, you snap to me. Is that taking?
Yes, sir.
So any other thing?
No, sir. Sir, are
So
you
the
still going to correct the this thing? The parameters they gave to you people.
it didn't give us any parameter.
What they will use to set up
Yes, that's
the
what we are using to pick questions for you. We are using what they gave us to pick questions for you already.
okay.
So
Okay.
did you get my answer?
Yes, sir.
What they sent to us, we are already using to pick similar questions for you already.
Okay, sir. Should I still plot the first one you gave to us?
Please do the two. Please do the two.
Okay, but sir, I wanted to know because I've already started doing that first one. But the current there, you
Yes.
said we should plot the graph of potential difference against current.
Yes.
So the
Yes.
but what I didn't get is the current is in 0.040.
Yes. So your
So
scale will be something like maybe 0.01 to 1 centimeter. So you will adjust your scale to something like that.
okay. So you were saying
Yes.
something yesterday, but my network wasn't very good. You
Yes.
were
What?
telling me about the scale. So which one is the 1 cm? Is it the thick line?
Yes. The distance between the thick lines is 1 cm, but some graph it is 2 cm.
Mine is yes, it's five small this thing. Five
Use your
small
ruler,
line.
to measure the distance between two thick lines. What's the
Okay.
answer?
Okay.
How
Okay,
many is
it's
it? How many?
1 cm.
Uh-huh. So that's 1 centimeter represents so unit, so ampere, volt. Exactly.
But I can still use 2 cm.
We are using 2 cm, it will be 2 centimeter represents so ampere, volt.
Okay, okay, sir. Okay. All right, sir. Thank you, sir. That's what I want to get.
So I want you to have some few minutes break before chemistry class. Is that okay?
Okay, sir. Okay, sir.
So please join your chemistry class.
All right. Thank you, sir.
Thank you for your contribution. God bless you. I'm paying attention. So let me send the link to this one.
I've not been able to open this link
The
since it's
challenge is that you will first download it will bring you to a point to download the software, the app, which is Microsoft. So if you don't download, you will not be able to open it. So that's why. But immediately you click on the link, it will ask you to download the Microsoft app. So if you download it, then you'll be able to see it.
okay. It's not the same with WPC.
No, it's not
W
the same with your not um it's not configured. Their configuration is not the same.
Okay, sir. Thank you, sir.
Hello, sir.
Yes, brother.
Uh, I need this specimen and the notes.
That's what I'm saying, that I've been using the apparatus they asked us to provide. I've been using it to give you questions. So please treat these questions I'm giving you.
Okay, sir. What of the notes? He sent to us.
Okay, it's all right. I will send. So please have like 5 minutes break before your chemistry class. Good night. So we continue from there tomorrow. Is that taking?
So I was still going to have tomorrow.
Yes, we are having. Oh, hold on, let me check the
Those that have
timing.
those that have exam on Saturday, the
Okay,
jam.
so if we have exam on Saturday, no, we won't be having tomorrow. Let me check when next we are having. So that will be
It's like
on.
we're having tomorrow, but because of the jam, can we reschedule?
Yes, we will have the next time will be on Monday 6 to 8 p.m.
Okay, sir.
Yes.
All right. Thank
Monday. You are welcome. Good night.